Hello students, this is Mr. McAllen, and today we're going to talk about the basic start of what an inverse is, or an inverse function, or an inverse relation. Basically, an inverse is the opposite of what you just did with math. For instance, there are many examples of inverses. If you have let's say you're solving an equation, 3x plus 4 equals 13. So you would do the inverse operation of adding 4 to get rid of that addition. So you would subtract 4, and you would have 3x equals 9. And now you would do the inverse operation of multiplying by 3 by dividing by 3 to find your solution. So when we seek out to find inverses, inverses are basically the opposite of what was once done with a function or a relation. So for example, I'll just use a function box analogy. Like if we have a function and we put x's into it and we get y values out of it, what an inverse path would be, so this would be like the function path. Let's just say it's a squaring function. And if you take values like 3, 4, and 5, you're going to get out of it 9, 16, and 25. Well, we want to have an inverse operation to go back. So the inverse operation is where you put, we want to solve for what the inverse function would be, or inverse relation. And so you'd want to take the output, 9, and map back to the 3 value. So this is the idea of what an inverse is. So the first most basic important thing about an inverse when you're looking at trying to find one is, well here, let me write most important thing conceptually. The most fundamental thing is x and y pairs switch. For example, the input becomes the output and vice versa. So let me show you an example of that. Let's say I had a table of data. This would be the first way that, if we were checking to see if you understood an inverse. If I had a table of 3 and 9, 4 and 16, 5 and 25, if we wanted you to write down what is the inverse table or inverse data, we would want to see that you would write down 9, 3, 16, 4, and 25, 5. This has particular consequences when you look at it on the graphing plane. For instance, I'm going to show with Desmos, like we all should know that, if we have y equals, let's say x squared, and it's on the domain from, well, let's not even worry about the domain, but if we had y equals x squared, and we know that its inverse function is y equals the square root of x, with a restricted domain, which we'll talk about later. But if we looked at that on a graphing plane, if I just put into Desmos, so let me bring Desmos up. I'll just pause the video while I get Desmos going. Okay, so hopefully you can see we have Desmos going, and I have f of x. Let's call that function. We'll call that x squared. And if I want to find what its inverse relation would look like, all I have to do is switch x with y. So if I do y equals, or x equals f of y, you could see, notice I switched the x and y pair. I get the inverse relation, if you would. Now, so the thing is remember that we always say that for the most basic part of an inverse is x and y switch. So you should always see when you draw or when you plot an inverse from data or from a function, there's this symmetry about the line y equals x. So as you can see here with the Desmos graph, the green line represents the symmetry over the line y equals x. If I pick up a point here, hopefully you can see I've got the point 2, 4. I'm just going to try to lock that point in. I'll just put in the coordinate 2, 4. So you can see the ordered pair 2, 4. Maybe not. 2, 4. Oh, that's my problem. I didn't hit a comma. So you can see the point 2, 4 on one graph, and if I do the inverse point 4, 2, you can see that it shows up in its mirrored graph. It shows up on that curve exactly. So this is the most important thing about an inverse, is X and Y pairs switch, and as such, if you were to plot them, you would see this symmetry across the X equals Y or Y equals X line. So this is a first introductory video. The next video we're going to talk about how do we recognize if an inverse or if a relation or a function has an inverse relation or an inverse function. So we're going to do that in the next video, so please tune into that. Thank you. I look forward to hearing your comments.